Good morning. We're going to be going over the answers to the introduction activity to some of the trends in the periodic table. And specifically, we're going to be looking at questions 11 and 12. Well, I'm going to go over 1 through 10 also. I want to draw your attention over here to the right side of the periodic table, sort of where my cursor is going up and down. These are the valence electrons for helium. There's 2 of them. That's a full shell. I see neon has got a full shell of 8, and argon, the third shell, is full of 8. So that would be the answer to question number 1. Name all the elements that have complete valence shells. Number 2, where are they located? Hey, these guys are called the noble gases, and I think in your periodic table you have them labeled that way. Number 3, which elements only had 1 electron in their valence shell? Okay, looking over here, I see 1 electron in the outermost shell. Right here, there's 1 electron in the outermost shell. Right there, there's simply 1 electron in that outermost shell. And finally, potassium. You guys didn't have to do potassium, but we can at least see the trend going on here. These elements over here in the far right column have 1 valence electron. And that's the answer to question number 4, or actually far left column. Far left column is where those elements are located. Number 5, what do you see as a pattern of the number of electrons in the valence shell as you go from left to right? Well, let's just pick out any row here. This is the 3rd period, and sodium has 1 valence electron, magnesium has 2, aluminum 3, oh my goodness, 4, 5, 6, 7, 8. If I go to the previous period, the 2nd period, lithium starts with 1 valence electron, 2, 3, 4, 5, 6, 7, when we get to fluorine, and finally 8. Question 6, what do you see going on in a column? Well, let's choose any random column. This column, 4 valence electrons, everything there. This column, everything has 7 valence electrons. This one, everything has 2, so it would appear as if that within a column. By the way, those are called families or groups, so if I ever say anything is a family, or if I refer to a group, those are the vertical columns. So vertical columns, they all have the same number of valence electrons. That could be important. So now predict the number of electrons on the valence shell for the following based on their location in the periodic table. Well, guess what? Barium is over here in this column, the 2nd column, so it should have 2 valence electrons. Lead is over here underneath carbon. It will have 4. Xenon is way over here. It has 8 valence electrons, and then finally potassium will have 1. In fact, there it is right there. What do you notice? Question number 8 now. What do you notice about the number of energy levels as you go down a column? Okay, this period has 1. This one has 2 energy levels. Every one across has 2. This one has 3 energy levels. This 4th row, the 4th period has 4. I bet the 5th period has 5. I bet the 6th period has 6, and the 7th has 7 energy levels. So predicting the number of energy levels for the following based on their location in the periodic table: iron should have 4, tin should have 5, radium should have 7, and gold should have 6. And then finally, question number 10. We're finally getting to the important questions. 10, 11, and 12 are the important questions. Atoms of elements become stable, meaning they have an outer energy level that's completely full of electrons. What elements are stable that you made cards for? Actually, that you wrote your models for? Helium, neon, argon, right here. Far right-hand side, those are stable. And those are called the noble gases, and it's kind of an old European term, noble gases, like the nobility in Europe. They didn't hang out with the common people. So these elements over here, helium, neon, and argon, they're kind of like nobility. They don't hang out and make bonds with all of the other atoms in the periodic table. So they're like the nobility in Europe. Now, let's get to question number 12, or 11. So question 11 will take us here. Okay, notice that we've got a question down here in red. So we're looking at this question. Some atoms of elements lose electrons to become stable. they lose electrons so that they get a full valence shell. What elements that you modeled are most likely to lose electrons? So I'm going to start this discussion with an example and talking about sodium. Now, if you look at sodium, it's right over here. It's number 11, and it's got one valence electron. So it could lose that one electron, and then it will have a full shell, or it could gain 7 to get a full shell. Now, in your world of logic, what makes more sense? To lose 1 electron or gain 7? And if you think about it just for like a split second or so, you think, well, losing 1 is probably going to be easier than gaining 7. And if you think that, you would be correct. So it makes sense to lose 1 electron to get a full shell. And then look at what happens to sodium. It is looking a lot like right over here. Look at where the cursor is. I'm way over on the right-hand side. It looks a lot like neon in terms of its electrons, but I still see that it's got 11 protons and 12 neutrons. So it's still sodium, but its electron arrangement is a lot like neon. Let's look at another question, or let's look at another element. What about magnesium? It can lose 2 or gain 6 to get a full shell. And what makes most sense? What's the simplest and easiest way to get a full shell? Well, yeah, think about it again for another split second, and you'll see that it's going to lose 2 electrons to get a full shell. Now there again, you see that when it loses those 2 electrons, it looks a lot like, right over here, it looks a lot like neon. And there is our magnesium, 12 protons, 12 neutrons. It only has 10 electrons now, but it's really stable. Next example is going to be aluminum right here. It's got 3 valence electrons. So in red, we see right here that it can lose 3 or gain 5 to get a full shell. In your world of common sense, what makes more sense? Losing 3 or gaining 5 to get a full shell? Well, losing 3. And again, look at what happens. You get a full shell of 8, and I see 2 electrons in the first shell, 8 in the second, and then when I circle over here, that looks exactly like neon in terms of electrons. But again, I'm going to remind you that it is still aluminum because it's got the 13 protons and it has the 14 neutrons in the nucleus. Now, let's look at your answer for 11. I probably want you to get rid of whatever you've written. And this would be a great answer, what I've got in red there. And yes, I'm encouraging you to either delete, or if you wrote it down on a piece of paper, erase it and write in this instead. And this is a regularity that you'll need to know. This is a broad term that you can use in a lot of different cases. Elements with 1, 2, or 3 valence electrons will lose electrons to become stable. Pretty simple. So take some time. If you need to pause right now and write that down, please write it down because I'm going to go on to the next question. But elements with 1, 2, or 3 valence electrons tend to lose electrons to become stable. Now, let's look at the next question, question number 12. Some atoms of elements gain electrons to become stable. They will gain electrons so that they obtain a valence shell that's full of electrons. What elements that you modeled, in other words, the ones that you drew models of, are most likely to gain electrons? And in the example here, we're going to look at fluorine. It can gain 1 electron to get a full shell, or it can lose 7 electrons. Let's just have a look at fluorine right here for a second. Its outer valence shell has got 7 electrons. It can lose them, and if it does that, it's going to look a lot like helium, or it could gain 1 electron. And oddly enough, what's it going to look like? It looks a lot like neon. So it gains that 1 electron, and you know, that makes a whole lot of sense. Gaining 1 electron makes a whole lot of sense. So that 1 electron is gained by fluorine, and you can see that they're right next door neighbors. They look exactly alike in terms of electronic structure. The only difference is fluorine has 1 less proton. So it gains 1 electron and it becomes stable electronically. Next example will be oxygen. What about oxygen? If I look at it right here, it's got 6 valence electrons. So to get a full shell, it can either gain 2 electrons or it can lose 6 to get a full shell. In your world of common sense, what makes the most sense? Yeah, it really makes a whole lot of sense to gain 2 electrons. And there it is right there. It still has 8 protons, 8 neutrons, but now it's got 10 electrons. So look at that. It becomes electronically very stable, just like the noble gas neon, yet it's still oxygen because it has 8 protons and 8 neutrons. So the name of the game in chemistry is to understand your electrons and to try and become stable with your electrons. Next example is nitrogen. There it is. It's number 7. It's got 5 valence electrons. So it could lose those 5 or it could gain 3. And again, it makes a whole lot of sense to gain 3 electrons. Now, now let's look at all of these that have either gained or lost electrons. How many of them are like neon? So if I start right here with nitrogen, our last example, it gained 3 electrons. It's got 10 total electrons. It looks like neon. Oxygen looks like neon. Fluorine like neon. And those are the gainers of electrons. And now the losers of electrons. Sodium, magnesium, and aluminum. So basically, if you have an electron structure like the noble gases, if you can get 2, 8, or 18, or whatever the other noble gases are, 36 and 54? No, that's not right. But whatever, if you can get an electron arrangement like the noble gases, you're stable. And that's kind of the important deal in gaining and losing electrons, is to have a full shell of electrons. Now, your answer for number 12 should be, and I want you to copy this down, it should be elements with 5, 6, or 7 valence electrons will gain electrons to become stable. And whatever you have in there is probably not a good enough answer. The answer that I have right here is a great general question that applies for elements with 5, 6, and 7. If your answer is talking about specific elements, it's not a really good answer, because I need you to think in general terms about elements becoming stable and elements with 5, 6, or 7 valence electrons gaining electrons to become stable. So write that down, please. Copy it. Now, usually when I go over the answers to this, I've got a Post-it note on my whiteboard, because there's always somebody, actually there's more than somebody, there's usually 3 or 4 people that will ask the question or raise their hands and wonder about it. And the phrasing of the question is always the same. And I'm sure there's a few of you that may have wondered about this or are wondering about it right now. And the question, when it is properly phrased, is this: what about 4? Yeah, what about elements with 4 valence electrons? What do? Do they gain or do they lose? Well, elements with 4 valence electrons can gain or lose. Either one. They could gain, they could lose. But most often, and especially if you are the element carbon, you're going to be sharing electrons. So typically, elements with 4 valence electrons tend to share electrons more than they gain or lose electrons. All right, I think this wraps it up for the answers. It's really kind of important to understand these general terms, these general ideas about gaining and losing electrons. It's really an important thing. It's really a fundamental thing about chemistry. And the secret to chemistry is know your electrons. And you got to know which elements will tend to gain, which elements will tend to lose their electrons. All right. I will see you all Friday at the conference on Friday. So we're having a Schoology conference Friday, and I will see you then.